Welcome to the deep dive. Today we're tackling something really simple on the surface, a food you probably eat all the time.
We are. Pasta, everyone thinks, flour, water, maybe some egg,
Right.
rustic stuff.
Exactly. But we're going to unpack the, frankly, astonishing complexity behind it, the history, the tech, the huge economic engine.
It's fascinating.
Yeah.
Because that simple meal, it's actually this masterclass in industrial precision. It links ancient history to what's now a massive $70 billion global industry.
70 billion.
Yeah.
That number really caught my eye. So for this deep dive, we looked at some detailed industrial analyses, factory process notes.
Yeah, the nitty-gritty stuff.
And our goal is basically to show you how that tiny grain of wheat becomes the spaghetti on your plate. And crucially, why these tiny, tiny details. They mean the difference between success and, well, millions in losses for these big companies.
It really is that precise, like chemistry lab precise.
Okay, so where does this journey begin?
Oh.
The wheat, right?
Absolutely. Starts with the raw material. And this is key. You can't just use any old wheat. Forget about your standard bread flour.
Right. That's the first big hurdle. Use the wrong kind, and it just fails.
Totally. The sources are really clear on this. Pasta needs hard wheat, specifically durum wheat.
Durum. And it's all about the high protein, the gluten content. Why is that so vital?
It's about structure. Durum wheat naturally has more protein and a much stronger gluten network compared to softer wheats.
Okay.
So if you try using soft wheat, the dough structure is just too weak. Cook it, and it breaks down, gets sticky, mushy, awful.
Right.
The durum structure, though, that's what lets the pasta handle the intense pressure in the factory machines and, importantly, stay al dente when you cook it. It's basically engineered for toughness.
So even before mixing anything, you've already built in failure protection just by choosing the right grain. That's smart.
It is. And getting enough of the specific grain, it's a global operation. Italy's famous for pasta, sure, but
But they're not growing all that wheat themselves.
not nearly enough for global demand. Huge amounts of high-quality durum come from these vast fields in places like Canada, actually, Turkey, too. It's a worldwide supply chain.
Okay, so the durum arrives at the plant. It gets cleaned, inspected, stored in these massive silos. Then what? The first big change, milling.
Correct. Milling is all about super precise extraction. You don't want the whole wheat kernel. You're after the core, the endosperm.
And there's a specific yield ratio here.
A strict one. For every, say, ton of durum wheat going in, you only get about 700 kilos of the good stuff out.
Wow, so nearly a third is removed.
Yeah. And that usable product, that's semolina. It's that coarse kind of yellowy grain. That's the soul of the pasta.
Semolina, rich in that specific protein and gluten we need for density, for structure. Okay, so now we're moving from the field into the factory. High-tech territory now.
Definitely. Precision engineering time. You take that semolina, you mix it with water. But again, hyper-controlled. The water content absolutely cannot go over 30% of the semolina's weight.
Why so strict on the water?
Because too much water makes the drying phase, which we'll get to, almost impossible to manage correctly. Sets you up for failure later.
Got it. Then comes the kneading. Intense, high-speed kneading. And here's where I found one of the biggest surprises. The whole thing happens under a full vacuum.
Yes. Inside these huge sealed machines. It seems counterintuitive, doesn't it?
Totally. Baking bread, you want air, you want lift. Why suck all the air out here? Wouldn't that make it too dense?
That's a great point. But for pasta, air is the enemy. The vacuum is purely protective. It prevents structural failure down the line.
How so?
Think about it. If you leave tiny air pockets trapped in that dough, they act like little weak spots. Later, when the pasta hits the heat of the drying tunnels...
The heat makes the air expand.
Exactly. Those little bubbles pop, rupture the pasta structure from the inside. It can literally explode the shape or just make it incredibly fragile. The vacuum eliminates that risk.
So it's about consistency, preventing waste, ensuring every single piece holds up.
Precisely. Structural integrity, that's the name of the game. So once you have this perfectly smooth, air-free, vacuum-kneaded dough...
Then you shape it.
Right. It gets pushed under enormous pressure through metal plates called dies. And those dies dictate the final shape. Spaghetti, penne, fusilli, lasagna sheets, you name it.
And this is where another subtle quality difference comes in, based on what those dies are made of. Teflon versus bronze. This was fascinating.
Oh, yeah. This is a big deal for pasta aficionados. The sources say that real traditional Italian quality often comes from using bronze.
Bronze? Why bronze?
Well, bronze is a softer metal. As the dough gets forced through it, the bronze leaves these microscopic scratches and ridges on the pasta surface. It creates a slightly rough texture.
Okay, I think I see where this goes. That roughness, It holds the sauce better.
Perfectly. It acts almost like, well, like tiny Velcro for the sauce, tomato
Yeah.
sauce, cream sauce, whatever. It clings beautifully.
Makes sense.
Teflon dies, though, they're super smooth and very durable. Great for mass production, high speed, less cleaning needed.
But the pasta comes out shiny and smooth.
Exactly. Smooth, maybe visually appealing in the packet, but sauce tends to slide off it more easily. It's less ideal for flavor integration.
So the big manufacturers are often choosing speed and machine efficiency over, arguably, a better eating experience with the sauce.
It's a classic industrial trade-off, isn't it? Bronze dyes wear out faster, need more maintenance. That slows things down if you're churning out millions of tons.
Shaving off seconds and reducing downtime adds up quickly.
Absolutely, it's a calculation. Volume versus that slight edge in artisan quality.
Okay, so pasta's shaped, it's still soft, still wet. Now comes what you call the most dangerous part, drying.
The high wire act, for sure. This is where everything can go wrong. The shaped pasta moves into these long thermal tunnels.
And it's not just blasting it with heat.
Oh no, incredibly meticulous. It's a slow process. They gently reduce the water content first, then gradually, carefully raise the temperature. The key is drying it evenly from the inside out.
If you dry the outside too fast.
The surface seals up, trapping moisture inside. That causes internal stress, micro cracks, disaster.
And the whole point of this super careful drying is to hit one magic number.
One critical number, 12%. The final moisture content must be exactly 12%, not 12.1, not 11.9, 12.0%. It's a non-negotiable chemical stability threshold.
And the consequences of missing that target, even slightly.
Catastrophic. If it's too high, say 13%, microbes can grow. The pasta basically rots over time, whole batch ruined.
Okay.
If it's too low, maybe 11%, it becomes incredibly brittle. It shatters during cooling, packaging, shipping. Again, huge waste, massive financial losses.
Wow, the source material said the testing is more precise than testing gold. That really drives it home. Millions riding on that 1% window.
It's intense. The 12% is why that box of pasta can sit in your pantry for like years and still be perfectly fine. It's engineered stability.
So once they nail the 12%, they're home free.
Almost. Cooling is next, and it's also critical. You have to bring the pasta down to room temperature before packaging.
Why's that?
If you seal it warm, condensation forms inside the bag or box. Moisture. And moisture means...
Microbes again. And probably discoloration, right?
Exactly. Color issues, mold risk. So proper cooling is essential. Then finally, quality control.
They test it again, even after all that.
Rigorously. Samples are pulled, they recheck moisture, recheck protein levels, and crucially, they cook it.
The boil test, what are they looking for?
Good pasta has to keep this golden color right,
Yeah.
have a nice cohesive texture, not fall apart, it shouldn't stick together in a clump, and it absolutely has to hold its original shape in the boiling water. Only then does it get the final okay.
Incredible. Okay, let's shift gears from this super engineered present back to the past, because there's a common story about pasta's origins that needs correcting, isn't there? The whole Marco Polo bringing it from China thing.
Yes, the Marco Polo myth. It's a great story, but historical evidence doesn't really back it up for pasta. The consensus now points strongly towards the Arabs.
The Arabs, how so?
About 1,000 years ago, during their time in Sicily, the Arabs were making, and importantly popularizing, dry pasta. They had a name for it.
Itria, the source is called.
Itria, flour and water, shaped and then dried thoroughly under the sun. And the reason? Preservation.
For travel.
Exactly. Long journeys, trade routes, military campaigns. They needed food that wouldn't spoil. It was a stable calorie source for people on the move.
And the Italians learned this technique from them.
That seems to be the starting point. They adopted the idea of drying pasta for longevity, and then over centuries perfected it, developed all the regional shapes and variations we love today.
So that 12% moisture rule we just talked about, the one needing million-dollar tunnels, it's essentially the modern industrial scale solution to the exact same problem the Arabs solved with sun-drying Itria a millennium ago. How to make flour and water last.
That's a fantastic connection, yes. Continuity through innovation. And that innovation took another huge leap in the 19th century. Factories were starting to scale up pasta production.
Right. But they had a problem with the traditional kneading method.
A big one. It often involved workers literally kneading huge batches of dough with their feet in large vats.
Wait, seriously? With their feet?
Apparently so. Obviously not very efficient, and let's just say hygiene standards weren't quite what they are today.
That's an image. Okay, definitely an incentive for automation.
You bet. And there's a great anecdote in the source material about King Ferdinand II of Naples. He wanted to scale up pasta making for his kingdom, so he hired an engineer.
A British engineer, Spadaccini.
That's the one. Commissioned him to invent the first proper mechanical kneader, and that machine basically ended the whole foot kneading era.
And allowed massive scaling.
Suddenly, yes, pasta production could boom. It went from being made in small workshops to being an industry capable of feeding entire cities, especially as they grew during the Industrial Revolution.
And that really laid the groundwork for the economic powerhouse pasta is today. That $70 billion global market figure is just staggering for flour and water.
It really shows the power of a staple food, doesn't it? Cheap, stable, versatile. Italy, no surprise, is still the dominant force, exporting something like 2.4 million tons a year.
To over 150 countries.
Wow. But it's not just Italy. Turkey and Egypt are mentioned as major producers now, too, especially in the Middle East. They're scaling up significantly.
And on the consumption side, who eats the most of this industrially perfected food?
While the Italians still lead the pack, about 23 kilos per person per year. That's a lot of pasta.
23 kilos.
But interestingly, Tunisia and Greece are right up there too.
Back to that Mediterranean connection, maybe, where dry pasta first took hold with Itria.
It really seems like it. It points to this deep, long-standing cultural importance of pasta in that whole region.
And the brands leading this global charge. Barilla is #1 worldwide, apparently, followed by other big names like Di Cecco, Ebro Foods, companies built on mastering that precision we've talked about.
Definitely. You don't get that big without nailing the process, from the durum wheat to the 12% rule.
So we've traced that grain all the way from the field through the vacuum chamber, squeezed out of a bronze or Teflon die, surviving the thermal tunnel. It's quite a journey.
It really is.
It's just amazing that this food we think of as so simple, so humble, is actually the product of some seriously ruthless industrial optimization. Specific wheat, that vacuum step, the razor's edge of 12% moisture.
And that, I think, is the big takeaway for you listening. Pasta's journey is like a perfect little case study of modern industry. Success isn't just the initial idea of flour and water. It's built on absolute precision, on mastering every tiny detail.
Texture, stability, shelf life. It all comes down to engineering.
Unwavering attention to those minute details.
So here's a final thought. Next time you're boiling water for dinner, maybe making some spaghetti.